Okay, hi and welcome to 24 Hours of Path Summit 2015 preview. We are excited you could join us today for Chris Bell's session, Hacking Exposé 2, Just How Transparent is TDE, a topic which I personally find very interesting. This 24 Hours of Path event consists of 24 consecutive live webcasts delivered by expert speakers from the Path community. This session is a preview of one of the many technical sessions that will be presented at the Path Summit in October this year. Recordings will be available in 1 week at 24hoursofpath.com. My name is Christian Henrik Reich. I'm a full-stack developer doing everything from JavaScript UI magic through backend and databases to stars, cubes, and reporting. For this hour, we will have a small agenda. I'll start out with a few quick introduction slides, and after my presentation, Chris will speak for 40 to 45 minutes, and then we'll move on to Q&A, where you can ask us any questions you may have. And next slide, please. Yes, thanks. If you have any question, or if you're experiencing any issues, just type your question into the question pane on the GoToWebinar control panel, and someone will assist you. Feel free to enter questions in the Q&A field at any time. Once we get the Q&A portion of the session, I will read off your questions to Chris. Since all attendees are muted, you will need to submit questions by typing in the Q&A field. Also, there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it. It will appear in your web browser after the session. Next slide, please. Thanks. 24 Hours of Path would not be possible without the support and dedication of our sponsors. They are the reason this event is available to you free of charge. I'd like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. In addition, I would also like to thank the supporting sponsors for this event, HP, SQL Sentry, and Pyramid Analytics. Next slide, please. Thanks. Next, I would like to bring your attention to the upcoming Path Summit. Taking place in Seattle, Washington in the last week of October, from the 27th to the 13th, Path Summit 2015 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, Path Summit is single-handedly the largest gathering in the SQL Server and BI professionals in the world. With over 5,000 registrants from all over the world, Path Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, Path Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Save $200 right now by using the discount code 24HOP15 when you register. Optimize your savings by registering before the end of Sunday, September the 20th. To find out more about Path Summit, visit pathsummit.com. Next slide, please. Thanks. Make sure you explore everything Path has to offer for data professionals. You can join our local user group around the world, virtual chapters, find free online resources through our Learning Center, and read up on the latest community news in the Connected newsletter. For those interested in business analytics, check out the Path Summit Business Analytics Conference happening in May next year. Visit pathbaconference.com for more information or to subscribe to our bi-weekly BA Insights newsletter. Next slide, please.
Mm-hmm.
Yeah.
Yeah, I got a little
And
bit
now, please. Oh, yeah, there's a little bit lag.
Mm-hmm.
But yeah. And now, please allow me to present the speaker of the hour, Chris Bell.
All right, thanks, Christian. Hopefully I don't have too much of a delay going on here with the slides. I'll try to keep an eye here on how things are moving along.
Yeah.
But yes, thank you for attending to everyone who's signed up on here. Welcome to Hacking Exposé 2, How Transparent is TDE? That is not a typo. 2 is because this is actually the second in a series, and I wanted to cover it as well, just to have some fun with the titles. So let's dig right into here. And let's take a look at what I actually want to go through today in this kind of preview, and also what I'll be covering at the PASS Summit. I'll be presenting this there as well. First, I want to talk about what is exposed when we're talking with SQL Server. And we're going to get kind of specific with some of this. We're going to define hacking and cracking real quickly. We're then going to go ahead and we're going to look at some data, but we're going to look at it streaming via SSMS when you log in. What's actually moving between your server and your client? We'll take a look at MDF and backup files and actually open that up and see what happens inside those files. And then we'll also talk about doing restorations of backup files. Now, the reason I want to go through these types of things are these are the activities that may actually happen resulting in data being exposed out there. Someone's connecting into your server, stuff is streaming through, we can grab that. Someone got onto your network, got into your server and grabbed a copy of your backup file. And are they able to restore it or not? And we can see what's available in that backup file if somebody grabbed it. We'll then go ahead and talk about what to do, and that is enabling TDE. We'll go through all the steps and cover one step in there that's actually forgotten a lot of times. And then we'll determine, does this really help? Is TDE the magic silver bullet that it has been said to be? And we'll do that by going through the same steps as we did in the what is exposed. We'll look at the data, streaming, the MDF, and also restoring a backup file. And we'll get to see just how transparent TDE is and if it covers everything. You did see my brag slide earlier. Here's my actual official one that I use all the time. I am Chris Bell. WaterOps Consulting is my company. I'm an independent SQL Server consultant. Past chapter in Washington, D.C., I help run that. WoxPod is a podcast I have every week. SQL Saturdays, I run the one in Washington, D.C. I also help out with the one up in Nova Scotia. Friend of Redgate, Microsoft MVP, and SQL Server, which means people think I know what I'm talking about. And also SPWOX compliant right there in the middle. I want you to go and download that if you can. If you get a chance, absolutely free, but it goes through and checks DoD state compliance on your system. It's doing a lot of security checks for you. I put that out there for free and it's constantly being updated. Really appreciate if you grab a hold of that and try it out if you are interested in the security settings on your systems. But enough about me and all that. Let's get into what we really want to talk about. How safe is your data? Well, first, we got to define what hacking is. And hacking, really simply put, is modifying computer hardware or software to accomplish goals outside of the original purpose. Of course, we all hear about life hacks and everything now. Well, that's the same kind of concept. We're modifying our life to accomplish goals outside of our original purpose that we were doing. You know, fun things like using Lego men to hold your charger cables, because it's just a fun little goofy life hack you can have. On the other side of that, you've got cracking. Now, cracking is the art of going in and removing or disabling undesirable features. You know, features like encryption. And that's kind of where we get into this. We're going to crack the codes, get in there, break it apart, and get into the juicy insides of all that data that we want to know what's going on in there. Now, through this session, I'm going to use a few easy-to-get tools. Just making sure this slide is loading up. I'm going to use a few easy-to-get tools. Now, what I'm doing here, I'm going to be showing actually a tool I use in my other presentation to sniff the network. And so I'm going to be looped in within my own network here on Hyper-V, and I'm going to sniff the packets as they're moving around. I didn't detail that in here, but you can grab that in my other presentation. And you can also contact me on Twitter or anything like that if you'd like to get where the tool is. But some of the other tools we can use, text editor. This is always a fun one. Notepad or Word, you can actually open up your MDF and backup files in those tools and search for store procedures and keywords and all that kind of fun thing. It's that plain text, how it's storing it. It's not the best tools to use. It's great if you've got a tiny little database. But once you get up to something a bit bigger, you start to reach the limits that Notepad or Word or some of these text editors have. But it found it really interesting playing that you could do a search for an SP underscore and start to see in the find results through through Word, you can actually start to see all your syntax written out for your stored procedures. But that's a little bit more in depth. We're not going to use that. I'm going to go real simple with a hex editor today. Now I'm going to be using XVI 32 or 1632, however you want to say it. There are lots of others available out there. Just go out and Google hex editor, download the one, and use the one you like the best. Another tool that's going to be easy to use that I think it's forgotten that it's a real easy tool that if you were a hacker or something, you wanted to steal someone's database and look at it, is actually SQL Server. As we all know, just for the cost of one email address, we can go and get a free trial edition of Enterprise good for 6 months. And what does Enterprise let us do? Everything. So I'll be using that as well. I won't be using a free trial. I'll be using the developer edition, but it's the same concepts in there. So now we got to know what we're up against and what we're doing with some of the tools. Let's dive right into this and start looking at some data and seeing what's exposed out there. Let's see if my switching around here is going to work nicely for me. All right, let me grab a couple of scripts I've got here. Drag these in here and get it going. You'd never know I just had to actually go through a whole reboot like 10 minutes before starting the presentation, would you? Well, I'm just going to let these load in here real quick. And these will all be available for you as part of the download package. You can get the video. You can also download these scripts so you can play along at home when you watch the video. We'll put these in some sequence that makes some sense to us. All right. So what I've got here is I've got a couple of machines I've got set up. One I've called Hacked, which is my local little machine here that I'm going to be using to put things on. And then I've also got my Hyper-V instance, which I'm just connected up through an IP address. It's got a couple of databases on here. And I'm going to actually use the AdventureWorks 2014 database. Why? Because it's easy to use. And there's some fun information in there when you dig into it. So I'm going to make sure I'm connected out to my remote system, hook into AdventureWorks, and let's fire up a fun tool. Now let's do a couple things. Actually, let's do a query first. This is a real simple, let's see, is my zoom it working? Oh, my zoom it's not working. I know, I hear it was like zoom in, zoom in. There, we'll get in here. I think I've got it running down here. Do I got it here? I know I've got it sitting here so I can get to it quickly. There it is. Hit the button, make it work. Oh, really, run. There we go. All right. So we can read some stuff in here. So I'm just going to go in and select some information out of the person.email address in my AdventureWorks database. Now it's going to be a real simple query I'm going to do there, but let's do something a little bit different with it. I'm going to go back here into my tools directory, and I'm going to run this tool called RawCap. This is the one I said I didn't write down, but you can go and get this one if you want. And this is a very, very simple standalone command line program that sniffs packets. Grabs them all, puts them all together into a dump file, and then I'm going to be using Wireshark to actually open up the dump file. Now, to show you how easy it is to actually sniff stuff on a network, I'm going to go ahead, fire up my RawCap, pick which one of my interfaces I want, which is 0, which is my loopback internal between my Hyper-V and that. And I'm going to run that. I'm going to hit Enter to dump into that dump file.pcap exactly in the same directory. Now, before you go and download this and decide to fire this off right away, be aware that this is considered hacking activities on most business networks. I'm pretty sure a good number of us have jobs, and I'm quite sure a good number of us would like to keep those jobs. So before you do anything like this type of sniffing, or the hex editing thing's not going to be so bad when we're digging in there. You can kind of hide that from everybody if you really had to. Don't recommend that. Make sure everybody knows what you're doing. But make sure you get permission from the right person to do these types of activities. And that doesn't mean go to your manager and say, hey, I want to do this. And he goes, yeah, that may not be the right person. It may be somebody in a security department. It may be all the way up into the execs. Just let people know that you're going to do this and get approval to do it. Don't go saying, Chris said I could do this. And no, sorry, I said you could do it, but I didn't say you could do it at work and just that way. But let's get that sniffing here. And let's go ahead and just pull another query. We'll run that same query in here, see if it's going to like me this time. All right, simple email results. Very simple query. This is something very realistic that you could do to go out and you're writing a report, you're running a query. This is just anybody working in SSMS pulling data across on your network. Well, what gets interesting is when we come over here, we'll notice a whole slew of packets have been coming through here, and it keeps counting up higher and higher as we go. Well, I'm going to go ahead and stop my RawCap switch into my directory and open up that dump file. And let's see what just happens. What was transmitted across the wire here? Because again, we're trying to protect our data. You've got to protect it in all different places, and not just one location. So let this fire up here. Okay, well, this gets really confusing. I can't dig in here and look through. Generally, what I look for when I've been pulling data queries and that out is I'll scroll down a fair bit through all this data up top. You see these 1500s max pack sizes and TCP segments. If I click on any one of these items, down here at the bottom, you'll start to notice some information that looks kind of familiar. Adventure-works.com. Wait, we're starting to see what look like email addresses. And we are, but I don't want to put all these little bits and pieces together and go through all of these. So Wireshark gives me a cool option to right-click on one of these items and follow the TCP stream. When I do that, it puts everything together for me and color codes. Now this is what's kind of fun. So this is basically what our communication was with to and from SQL Server. Red is what we sent, and there's our select statement. Select business ID, from our email address, and blue is what we got back, which you can see contains everybody's email addresses that we had in the company because we just dumped the table out. Just like to show that in there just so you know what is actually being thrown around on the network for us. But that's simple. It's there. We don't have any kind of protection on our database system at all. And this is what's just streaming around on our network. Yeah, a little bit of a problem if you're dealing with some sensitive information. So let's go ahead. Let's make a couple of backups of our database that we had. We've seen stuff moving around. Well, let's talk about actual backups. And these are just a couple simple backups, but I've done two different things here. I've got one that you notice has no compression, and the other one has compression. Same database. I'm going to do no compression, compression. Hopefully everybody is compressing our databases in here. Oh, this is being slow today. Wow. We'll let that catch up. But compression is kind of neat how it works, because if you've dug into it at all, you'd realize that compression goes out, finds similar patterns, and replaces them. So if you have something that starts with 3333 and it's all throughout a bunch of tables, and you wind up with with this pointer that says, you know, instead of putting 333, I'm going to put this other value in and put it back to my header, and therefore I'll store the information there and I can piece it back together, but it takes up less space, pack it down tighter. So our backups are done here. Now let's have some real fun. What happens if somebody, again, has gotten onto your network and we don't have SQL Server? They went out, they got into your file system, they got to your backup stores, and they grabbed your backup copies you have and downloaded them, along with everything else off of that file server. We don't know what it is. And in most cases, a hacker is not going to have any idea of what that information is as well. So they're going to wind up with a directory that may have a few items similar to this. We may have, these are a couple backup files. I've got some private keys, which should not be stored with your regular database backups. This is just for demo purposes. But you can see I have my uncompressed and my compressed copies here. And I also have a 2012 data.mdf that somebody detached and just put out there. Well, I've got these, if you notice, linked up not to SQL Server, but I have these associated with my hex editor, which is that hex editor XVI32. Did that just so I can click through here a lot quicker. But let's take a look at the uncompressed backup and just see what's in there. Now when I open this up in a hex editor, there's a couple of things right off the bat come up. You can see right at the very beginning of this, it says tape. Okay, so I probably have a backup to tape, and oh look, it says Microsoft SQL Server, so I know I have a backup for SQL Server right here. Well, that's nice and convenient for me. Maybe as a hacker, I've written a tool that'll go in, fire up some hex edit, open up the tool here in hex code and edit through that, and I can start to search for certain keywords like tape and Microsoft SQL Server. Oh, I can now tag this file as no matter how they've named it, maybe .back, maybe BCK, so it's not a standard default. You think you're fooling everybody. Well, we can dig in here and start to see that information of what's showing up. But beyond that, if we start to scroll through, it'll start to look like there's some real junk in here. And it is until you start looking a bit closer and realize a lot of this is just plain text and just all crammed in together. So what kind of stuff that could we search for in here? Well, if we happen to know an employee's name, I'm going to actually use my wife's name, Gigi, because it's really funny, but AdventureWorks has a Gigi working in them. If I do a search on that, oh look, suddenly I found a GG. And not only did I find a GG, I found GG0@adventureworks.com. Oh, I found email addresses. In fact, if we keep reading down through the hex file here, you can see I have a lot of email addresses. Cool. I can basically dump your table out of this with a little bit of scrubbing that without even using SQL Server and get everybody's email address. But email addresses are nice. I mean, we can spam people and do that kind of thing and sell them, and it gets annoying. But what really messes with someone's life is their credit, right? Somebody takes your credit card, something like that. Well, let's see if the common word, if maybe we're storing information here in this AdventureWorks company as credit. And I can do a search. Well, I got credit rating. That's not exciting. What's my next one? Oh, look at this value that came up here in the middle of a query. Credit card ID. Well, that's interesting. So that's going to imply to me that in the database, credit cards are stored somewhere and they have an ID associated with it. Well, let me modify my search now for a credit card ID. Now, one trick if you're going to use this XVI32 is mark this as Unicode Latin. That lets you type in your plain text English like this, and it'll find it even though there's spaces and other gaps that are in the side here. It'll actually piece it back into Unicode so you can try to find it. So let's start looking for credit card ID. Of course, we're going to find the one we just did. I set mine to start searching from the beginning every time. But as we go and skip through here, we go, oh, there's another credit card ID. Okay, but it's not telling us anything. What we kind of want to see is there anything in here that's defining what credit card ID is? And I can see I've got other keys together. I've got a couple things like credit card ID and this. So I'm seeing some kind of query in here probably, which also goes and says, well, now I can actually start to dig through the file here and figure out your store procedures and how you actually put your data together. That starts to get interesting, doesn't it? There's all sorts of fun stuff just sitting in here. Oh, wait, we found something interesting here. Look at this. What have I got? I've got credit card ID, integer, and null. Well, yeah, I kind of guessed it was probably going to be an integer or something like that because it's an ID value, but null. This looks like more like it's putting something somewhere, maybe an insert statement. But credit card ID seems to be a valid thing, and it's going somewhere. So what if we keep looking and start digging through and look for another one that maybe has that definition like integer again? Like, oh, what have we got here? So I can see I've got credit card ID, integer, identity11, not null. Oh wait, this is a table definition. Right after that I can see card type, which is an NVARCAR50, not null, and card number, NVARCAR25. Now this gets interesting when you start looking at card number, NVARCAR25, especially and not null. But what gets really interesting for me is seeing NVARCAR25. Most times when we encrypt data or we encrypt something like a credit card number, we actually store them as binary in our SQL databases. Well, when I see this and I go, I have a credit card number and it's stored as a variable character that's 25 characters long, what's happening? It's probably being stored as plain text. And now I don't have to go and go, oh, it's encrypted, I got keys and all this. Like, well, wait, if this is being stored plain text, maybe looking on a pattern that is used when you put in these credit card numbers for where we are or wherever, I may be able to actually start to find some of those plain text values and just from my X editor pull those out and find exactly what I want. The trick to doing that is to look for the certain patterns that a credit card number would start with. Or we also know we have card type, and maybe that's the name of the card. Now in our world, we have Visa, MasterCard, Amex, other cards like that. And if you go out on Google, you can check real quick, and you'll see that MasterCards are identified by the first two numbers in the card numbers start with a number between 51 and 55. So any of you out there, if you want to grab your MasterCard right now, take a look. I'm guaranteed it's going to start with 51, 52, 53, 54, or 55. Okay, if you got a Visa, it's going to start with a 4, and if you have an Amex, it starts with a 34 or 37. That's what's been done in history. That's how we can identify what type of card this is. Well, the thing is, if I look for any of those things, I may randomly find the 51 in here, but I'm not going to find the credit card because this is AdventureWorks, which lives in its own strange little Microsoft world. But in that world, there's a few other credit cards. There's these cards called Superior Card or the Distinguished Voice Card or Colonial Voice and Distinguished Card, and they have different patterns to them. In fact, Superior starts with 3333. So if I do a search on that through my database, oh look, I found something here. Let's see what this is. If I come in and take a look, you can see here, it's kind of messed up a bit in here where I'm looking. There it is. Get my click in the right place. I've got a superior card. I'll zoom in this in just a second here. I have a superior card, and there's my pattern of 333-4394-4999-320. I just found a credit card sitting in the hex file, and I did not touch SQL Server at all. Not only that, we keep going down. Look, there's a distinguished card 2 lines below it. There's a distinguished card with a card number right after it. There's another distinguished card. There's a superior. I just found a table in here holding a whole lot of credit card information right there, right for the picking. Again, not even using SQL Server, just opening up in a simple hex editor. Well, what if I had the compressed backup? Now, hopefully everybody's using compressed backups. They make a lot of sense in there. They save you some space. In most cases, not all. We'll touch on that in a little bit. But what happens when you have a compressed backup and we come in to look? As mentioned earlier, compressed backups work by taking repeating values and kind of putting in a pointer and changing and shuffling it around a little bit. I actually wrote about this, I think, in my blog last week, basically saying it's like poor man's encryption. If someone's grabbing a hex editor here, there's a couple things I can grab from your compressed backup file. What was kind of fun was to see they even compressed the Microsoft SQL Server tape down to MS SQL back. So I know this is still a Microsoft SQL backup. It's the very first thing it's telling me. The rest of this is kind of gibberish in here. And again, this is that compression coming into play here. If we start to scroll down through this, we'll start to notice this is really a bit of a mess, and I'm not making much sense out of it. And that's due to the compression algorithms. A little bit different than encryption algorithms, but they're kind of doing the same thing when we look at the raw data. And that's kind of cool that we can go in and say, hey, I've got some stuff that somebody grabs and goes to scrub through here. If I start looking for, if I know an employee like Gigi, if I look for that, I'm not going to find that. Remember, this backup was taken at the exact same time with the exact same database, so we saw it in our non-compressed backup. Well, what about if we look for, we had card number. Look for card number. Oh, we're not going to find that either. Okay, credit, spelt right, might actually find it. No, we're not finding any of that. And this, it worked really nicely here and hid that from everybody. So we can actually get a little tiny bit of security from there. Except that when we open that up, we knew it was a Microsoft SQL Server backup. So if I didn't have SQL Server, I can go give my email address, get my free copy, come in and run a restoration of that compressed backup, which of course for me it doesn't want to be able to open for whatever reason. I think I got my path in here incorrectly, but we'll see. Oh, I know why that's wrong. It's these ones over here. Da-da-da. Yay, demo gods. Dropbox reason hang us. Let me double check my directory there. I thought that was the directory I had it in. It's just not liking me. Oh, I know why it's doing that. Sorry, I forgot to change my connection to my local machine that I pulled my file down to. If I read my own notes, put them in there for you guys. I should have them in there for me too, right? Put that in here. I've copied that file down off the server. I fire this up and run it. And even though it was a compressed one that my hex editor couldn't see anything in here, we can see that it's going ahead and doing the restore fully for me. Give that just a couple seconds there. That'll finish up. And then I can come up to my local system here. We'll give it a quick refresh. And now I can actually go and get into my AdventureWorks, expand out my tables, and, well, again, I've got everything in here because on my system I've installed it in, obviously, as a sysadmin. So if I want your credit cards, I can just come in here to my select top 1000 or however I would want to query against that. And boom, I've got all those credit card numbers. Fun, isn't it? This is fun stuff. You're sticking around, so it's going to be some people left. But yeah, you're mostly just sticking around, so you must be having some kind of fun with it. So yeah, so now comes up the question of how do we deal with this? Well, that's what we have transparent data encryption for. It's been plugged as, oh, it's a silver bullet, it makes everything great, if you have your application running, this will help protect things, da-da-da-da. Yay, marketing. It's there, it's been around for a while. Now, it was introduced in SQL 2008, which I'm sure a good number of you are still running, as well as 12 and 14, and some moving on to 16 pretty quick. If you're still running 2005, sorry, you don't got this. Now, the downside is it was introduced in SQL 2008 as an enterprise-only feature. And it is still only an enterprise feature. I don't know if it's coming out in a standard or anything like that anytime soon, but you know, it's unfortunately at this point in time, it's still enterprise. Talk to me at Summit, and we'll see if it gets any better. Now, the goal of transparent data encryption is to protect data at rest, and this is primarily done for compliance. And compliance with what? Well, there's different regulations we have in the world. You probably have heard of a lot of them and really familiar with things like HIPAA and PCI and DoD STIG. Now, DoD STIG is kind of focused. It's one of the things I've been writing about a lot, and it's what the SPWAS compliance script checks right now. Those are the Department of Defense, the U.S. Department of Defense Security Technical Implementation Guidelines. It's a great guideline of how to start to secure your systems down. Covers a lot of what's covered by HIPAA and PCI. They get a little more focused on what they're doing, but the DoD STIG is a great guideline if you want to start protecting your data. But there's that whole protect data at rest. Well, great. What does that mean? Well, that means that we're going to be encrypting the databases, but we're going to be doing it on the hard drive or on the backup media. We're not going to be doing it in memory. We're not going to be doing it in transit or anything like that. It is just at rest, sitting on the hard drive and sitting in the backup media. So there's some steps that we have to do to secure our database using TDE. First, we need to have a master key. And we're going to do that in the database. I've got this in the scripts. We'll take a look at this in just a second. Once you've got that master key, you're going to have to create or obtain a certificate. From there, we need to get a database encryption key. So here we're already getting 3 levels of security in. I got a master key, a certificate, and then an encryption key. Well, just so you know, there's 2 other layers above that. The master key in step 1 is actually protected by the service key that's generated in SQL Server, which is then protected by the security APIs in Windows. So you actually have a couple of layers above that. So we're actually 5 layers deep in here when it gets into security. Now, generally you do these 3 steps, and you do step number 4. You go into the database and you enable encryption. And if you've played with TDE before, you would have done this one great. The thing that most people forget is that you need to check that the encryption has completed. Now, TDE works by going out, and it basically starts encrypting the database in the background as a background process. So you can keep using the database while it's churning along in the background, encrypting information. If you're putting TDE in because you need to be compliant with something, you may have to actually not let people back into the database until the encryption is completed. So let's go take a look at enabling TDE and then also checking to see did it really do anything for us when it comes to looking at our data. So I'm going to go over here and make sure I'm connected once again to my Hyper-V system. Go over to the master database. Now, I already have a master key created, but I include the code in here so you can do it. Use good, strong passwords. These are demo level passwords, but you can go a little bit stronger if you like. They're decently strong, but make up good passwords if you're going to be doing that. See the syntax to create a master key encryption by a password. When you do that, make sure that as soon as you create any of these keys or certificates, the first thing you do is make backups of them. Okay, fit it into your regular backup process as well, because you're going to see what happens, because if you lose your keys or your certificates, guess what? You're going to lose your data if you have to move it or try to restore it somewhere. So you want to make sure you get those backups made right away. Create key, simple, real simple, create master key encryption by password, boom. Back up the key to a file, encrypt it with a password, give it a strong password as well, and store that somewhere that is not where your backups are and not on the server itself. Get it out somewhere cloud. If you really want thumb drives, other servers, just off the site and that, so you have them there just in case. Once that master key has been created, I'm going to go ahead and create a certificate, and it's going to use that master key to encrypt it. So I'm going to have this certificate called My Hacking Cert, using a subject of My Hacking Certificate, generate that, and then immediately back that certificate up. Now, the backup's a little bit different here. You notice I'm going to back up to a file, and that's fine, but then I have a private key, and that goes to another file there called SQL Private Key file, and it's encrypted with a password. And what that is doing is breaking my certificate into 2 pieces. So somebody got a hold of my TDE cert file but did not have the private key file. They can't put it back together to use it somewhere else. The goal of all of this is to have that extra protection, get the layers in here. We're going to do this by making a couple of files that, when put together properly, create our certificate to be restored somewhere else. And we'll cover why that's important in a little bit. So I'm going to go ahead and get this certificate created. Nice quick results there. And now I'm going to switch over to the database that I want to protect. Here, we'll zoom this in here like this for you guys. So I'm going to go ahead, use my AdventureWorks database. I'm going to switch over to there, and I'm going to create my encryption key within the database itself. Simply put, create database encryption key with algorithm equals AES 256. I would recommend that at a minimum. That's a 256-bit encryption level. That is I think the current minimum level for U.S. military encryption is AES 256. I'd have to double check that. But then we're going to tell it to encrypt it using that server certificate. Remember, which then is encrypted by the master key, which is encrypted by the service key, which is encrypted by the API. This trickle-down effect is happening there. So we're going to create our database encryption key, and then I'm going to alter my database, and I'm going to set encryption on. So once you have all these parts in place, and you can go ahead and you can back up this key if you really want to, but because we're encrypting with a server certificate, we can easily recreate this key. Notice it doesn't have a name. It's just create database encryption key with algorithm. We didn't have to give it a special name. The certificate is what's doing this, and this is only going to be used for TDE, not any other kind of encryption we may do within the database. So that's why you don't see a backup command right there. So I'm going to go ahead and alter the database, set encryption on, but as soon as I do that, I'm going to jump down here to this little script. You can see pulling from the system view of DM database encryption keys and joining to databases. And that will give me a status of how far we are in the encryption. This usually goes pretty quick, so I'm going to fire that one off real quick, and you see that says it completed the encryption, but when we run this query, we can see that we're maybe not quite completed. Now take a note, 0 is no encryption is there, 1 is that it's unencrypted but a key is available, 2 is that it is currently encrypting, 3 is that it's encrypted. Well, as soon as I hit that message up here of set encryption on, it came back and said, all right, I'm done. Well, yeah, it was done setting the flag, but it had to start the encryption process, which you can see with our AdventureWorks. It started right here, database ID 5, encryption state 2. I am still encrypting. It is not fully encrypted yet. This is important to keep an eye on if you turn this on. Now, it does give the dates of when the keys and that were generated, and we'll zoom in down here. We see a little bit more information. We can see we have the key algorithm is AES. It's 256-bit. We can see the encryptor thumbprint, which is the unique identifier essentially for the certificate that I have of the encryptor type certificate. And you see that when I ran this query, only 28% of my database had been encrypted, not 100% like we may have assumed when it said that it had completed successfully. You may have also noticed another database here suddenly came up in the encrypted, and that is TempDB. And this is one of the downsides you get with using transparent data encryption is TempDB will be encrypted. It does it very quickly, but it doesn't use your certificate. It creates its own asymmetric key. Now it does this because anything that we take, we may go and put into the TempDB using, if we're doing some calculations, some sums, some other temp tables and that in our encrypted database, it goes into TempDB, we've got to protect it there too. So how do we do it? We protect TempDB as well, which means we protect it for everybody using it. Now I've included the ways to turn off encryption and that in here, and that's what I'm going to do real quick. I'm going to actually come in here, use my AdventureWorks, get back over there, and I'm going to turn my encryption off. Now when I do that, I would drop my encryption key right away, but I usually will get an error because now it has to decrypt everything. So it takes a little bit of time for it to decrypt. But once that decryption is done, then I can go ahead and say it's still not done. You know how to check that it's done? Yeah, I use that script that's up here. Come here and see this. It's on a 1, and it's saying 0% complete, which is the same as 100. So now I should be able to drop my encryption key. Now I drop my encryption key, go back to my master. I can drop my certificate as well. And when we come back and run our query to see the status of all of our encryptions, you will notice that our AdventureWorks is no longer encrypted, but our TempDB is. Well, yeah, TempDB has to stay encrypted, because it may still hold information in it. Even though we've turned the encryption off on that one database, it may still have something that was encrypted at the time. And we know with TempDB, it's not going to go and undo this encryption until it makes a new TempDB, which we know is only with a restart. So just as a little side hint, that if you've played with TDE in the past and did it on one of your servers, and you haven't restarted that server since you turned it off, you're actually taking a performance hit on that server of, on average, 3.5% to 4% CPU overhead for maintaining TempDB in an encrypted state. So if you want to gain that little 3.5%, 4% back and you've turned off TDE, make sure your TempDB is not encrypted anymore. Restart that service and that'll clear it right up for you. Now, even though I turned that off, I am actually going to go and turn it back on real quick. So I'm going to create this certificate. Again, real quick, we'll fire that off real quick. I'm going to put this back on, so we got a few minutes left in here. We can do some stuff. We'll get it created, turn on the encryption. Now notice, I did not do the backup when I made the certificate. SQL Server actually goes, hey, wait a minute, you made a certificate, but you didn't back it up. It actually tells you that if you don't make the backups. Now, I do have a backup of it, but it basically says you should back it up, and the private key associated with the certificate, if it ever becomes unavailable and you must restore attached to another server, you have to have backups. See, so I wasn't kidding. Microsoft even tells you back up your certificates and keys. As you can see, you will not be able to open the database. But we'll keep it happy. We'll make a quick backup of it just so that it's happy. Oh, of course, because I'm in the wrong database here. Put that up in master real quick. So now, because I already made the backup earlier, this is the other issue you get when you try to back up certificates. Because I already have the backup made, you can't overwrite the one that was there. You'd have to rename it as something else. So we'll go ahead and we'll stick a 1 on these just so that the system is happy. There it is. It's all done and happy there. So let's have some fun. So we did turn on our TDE. All right, let's double check. Make sure it is still on and that our server is done doing its update. We've got AdventureWorks 5. It's encrypted state 3, which means our encryption is done. So it's all protected now when the data is at rest. Well, what does that mean? Well, let's find out what that means. Let's go ahead and get that rawcap tool running again in here. Lots of directories. Let's get rawcap running again. We'll go out to my Hyper-V, just get that dumping. That's how quick you can fire that off. Isn't that kind of scary, guys? I think that's kind of scary. Let's make sure that I'm hooked up to the database I need to be on. Use AdventureWorks and fire this off. There's our query. Jump over here. Close out our packets, our grabbing of the packets there, open up our dump file. Now we've turned on transparent data encrypted. We have an encrypted database. Yay, our data is protected. Or is it? Well, as we said, this protects at rest. So when I start to come down here and see the current dump that we just did, grab these TCP segments, put it all back together, what have I got in here? Now, yes, it looks like some gibberish up front because I did a couple of extra steps and connections in here, but as I come down, here's my red select statement that I had. Select this, and notice right below it, here's everything plain text. We're protecting data at rest. Data when it's moving from server to client and client to server is not at rest. So even though I did that, somebody sniffing my network, if they got in there, they could actually still grab everything I had in there. Well, that's a little bit of a transparent aspect in there. All right. Well, what about if we make our backups? Well, we'll grab a couple of backups out there. Notice these are labeled with TDE uncompressed and TDE compressed. We'll give them some time to fiddle along there, but let's go and open up one of those. I actually have some copies of those ready to use for you guys in here. Let's take a look at the uncompressed backup file. Now remember, TDE encrypts our MDF, NDF, LDF, backup, and transaction files. So if I come in here and open this up in a hex editor and open up the uncompressed backup, well, I know it's a tape, and I know that I've got Microsoft SQL Server. Okay, I still know it's the backup. But as I start to scroll down through, I have absolutely pure gibberish. This doesn't make any sense to any of us. If it does make sense to you, you should be sitting on a beach raking in some cash because you're able to break 256-bit encryption. More power to you. But yeah, we're not seeing anything here. We try to do some searches. We search for strings. If I find something, it's going to be completely random that I find something because this is encrypted data here in the file. Compression or no, it doesn't matter. I can't find these. And we already knew what we had with the compressed backup before. We couldn't make sense out of it when we were in the file itself, but what if I try to restore that now? So let's say I'm going to hook over to my little local system because I pulled your backup files down. And I'm going to come in and I'm going to attempt to restore that compressed backup because I know it was a backup. It's compressed, so I can't find anything in the raw file. Let me go ahead and run this here locally. See if it's going to like me. Oh, it didn't like me at all. Non-qualified transaction to be rolled back. That's fine. Cannot find server certificate with the thumbprint 0x27 blah 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 blah. Restore database is terminating abnormally. Yes, that's the idea. You do not have my certificate and my keys to be able to restore this database because I've made the backups and put them somewhere safe that they were not where you grabbed it when you grabbed my backup file. What happens when you've got to restore it somewhere? Well, you got to do a couple of things. You're going to need that master key. You're going to need that certificate. So we had our master key there. We're going to wind up restoring it onto our secondary system. So we go out, we say from our file where we have it, we have our decryption password, the one that it was encrypted with before, and we're going to, when we restore it, we're going to encrypt it with a new password. Now, SQL Server is quite smart that if you've had this key and you've restored it already, it will actually come back and say, hey, your old and new master key are identical. I don't need to do any re-encryption. Because when you restore a key from a backup, the system actually has to go and decrypt everything from before and re-encrypt it with the new key. And as you can imagine, depending on how big your system gets, that can start to take some time. This one is nice enough, SQL's smart enough here to go and say, hey, this is the same key as what I had. I don't need to do all that work, which is a nice little side effect I've got of having a demo system that already had that on there. But I can create my certificate. I do have to say from the file with the private key. We'll zoom that in a bit for you there. So I've got that file, I got that private key, I have to decrypt it with the password I encrypted it with, but then this will go and create my certificate that I can use for that transparent data encryption system. Get that back in here. Once that's there, then my regular restore command will come along and we'll see that this should, say that, there it is, it's running properly, I'm getting my full restore back on the database that is encrypted. Now what gets fun is that if I come back over to my other query here and make sure I hook up to my local system here, when I pull this out of here, even though my Temp DB was not encrypted before, just the act of restoring a TDE protected database automatically went and encrypted the Temp DB. So you got to be aware it's always going to encrypt that Temp DB. So we got to see how the restores and all that work in here. So let's start to close this one down here. We're running short on time. So there's a few gotchas you got to be aware of. You're going to see increased overhead. Okay, one, because of TempDB being encrypted. We talked about that earlier. 3 to 4% lost in the processing on your system if you leave that TempDB encrypted if you take TDE off. So you play with this and you take it off of that, just know that you're going to have to want to restart that service. And you're always going to see an increased overhead anytime you put protection in place, any kind of encryption, because, well, it's thinking. I have to encrypt stuff. I have to do math. Your server has to think more. You're always going to see a CPU increase. How much? You know what? It's the standard thing you always hear. It depends. It can be anywhere from 3 to 4% all the way up to 70, 75% CPU increase. So just try it out, test it, make sure everything works out okay. You may also have some possible downtime, and that would be waiting for the TDE to complete. You may have stuff that is sensitive enough that you need to have it protected before you can get into it at all. Therefore, you've got to wait for that TDE to be finished before you allow everybody back into your database. So you may have some downtime in there. Some other little things you get, TDE and backups. Well, we mentioned backup your keys and certificates. That's important. If you don't have it, you can't restore the database. We saw that working. It's a nice level of protection. But you also can't detach and attach your MDF file and LDF files to another machine because you'd have to have those keys and certificates over there as well. And not only that, if you go, well, fine, I'm going to go into SSMS and I'm going to use the copy database wizard. Guess what? You can't. It doesn't let you do that either. It's going to require those keys and certificates to be on your other system you're copying it to just the same. Dealing with backups too, we talked about backup compression. Well, you get a loss of compression. Backup compression suffers quite a bit. In fact, how much? Well, let me show you just how much. Let's go and look at our original ones I had in here. you can see my compressed backup was here at about 46 meg, and my uncompressed came in at 195. It's a nice saving. I got 75% reduction there. That's pretty darn good. I'm pretty happy with that. But when you get into transparent data encryption, you'll start to notice that our compressed versus our non-compressed are actually pretty much about even. Got a little bit of stuff compressed in there because now I don't say Microsoft SQL Server tape, and now it just says MS SQL back. But I still wound up with it being about the same size. And that's the whole thing of encryption happening. Encryption changes all the values, so they're all different. So now I can't find those matching patterns, and I can't go ahead and kick that stuff out and pack it down nice and tight. There is one advantage, though. If you're using page and row compression, which occur in memory in that, and then get into the disk as compressed already, that will still remain. That will continue to work for you. You don't have to worry about that. So if you are concerned about packing things down tight and you want to put TDE in place, but you know you're going to lose your backup compression, you may want to look at putting page and row compression in place to help reduce the sizes of that and work in conjunction with TDE. On a final note to close out, there is no... Yes?
Yeah, we are running out of time.
I'm just finishing up here. This is like last little bit right here. So I'm about to get you in for the last little bit. So there is no single solution. You got to protect your data at rest. TDE is a solution that column level encryption protects it within the database as well. Data in motion, we've got SSL and TLS. This is our communication protocols, and file and network encryption tools like IPsec. And our keys and certificates, use strong passwords if you got them in there, and look at EKM systems. If you're already up at enterprise level systems, you're talking external key management, extended key management systems for this as well. So, quick review, data is not encrypted by default. We need to set up keys and certificates. You need to back up those keys and certificates, enable encryption, and then there is no one solution. Data is at rest, has to be protected, data in motion has to be protected, and look at separation of duties using those EKM systems and moving stuff out of there. And when it comes to this protection and security of your data and being hacked or cracked, remember, it is not if, but when it is going to happen. And on that, I will open up to any quick questions, and that I'll answer them as fast as I can. I'll recycle some old answers. And...
Yes, we have a question. It's regarding the packet sniffing. And the question is, does it matter if the connection is forced encryption or not?
The force encryption, there's a couple places that you set that. That does matter to a degree. If you set that up on your high level on your SQL one, where you can say force encryption, yes, that will protect that. If you're using certificates in that, you're going to have your certificates, your SSL certificates on clients and hosts and servers and that to get that communication through. I actually cover that in my other sessions, so I'm not going to dig too deep into that on this. I want to make sure I get questions answered for this session, more focused on the TDE. Yes. Good question, though.
Yeah, but yeah, definitely. Actually, you did such a good job that there's no other questions.
Oh, that means everyone fell asleep. Well, again, if anybody's got questions, you can email me. You can get me online, CBellDBA on Twitter. Here, I'll give you that next slide in here if you like. Contact info from me down in the bottom corner. But I will hand it back to you, Christian, so you can go ahead and close this one out.
Yeah, thank you very much. I also would like to inform you that Chris is entertaining speaking at PAS Summit, and he's speaking on the Friday, the last day of the summit. And I encourage you to go to the summit. It's a very good place to be.
The summit is amazing.
So, yeah, definitely. I guess there's one more slide. Yes, I would like to thank you for attending this session, and I would like to thank Chris for his time and his expertise. And again, I would also like to thank our presenting sponsors, Microsoft, Idera, and Dell Software, and also our supporting sponsors, Pyramid Analytics, SQL Sentry, and HP. We hope you enjoyed this session as much as we did. Follow along on social media with the Path24Hub and share your thoughts on the event with hashtags Path24Hub and SQL Pass. And there should be one more slide.
Coming up next.
Oh, thank you very much.
Yes.
Stay tuned for our next session.
And just a quick note to everybody on here, please do fill out those surveys that come up as soon as you close this session. Those are very valuable, not only to Pass, but to me. I'll get fed some of that information so I know how horrible I did or how great I did and what to improve.
Yeah, I would also like to spend 10 seconds to tell you that people are writing that they did not fall asleep. So you did a good job.
Yay!
Stay tuned for our next session, visualizing data, the good, the bad, and the ugly, with Stacia Wager happening